Recall the last time we talked about optimal area and perimeter when it's related to a rectangular shape that a square would do that. So a square would have four of the same sides where the area is, if we called these sides, side squared, and perimeter would be side plus side plus side plus side, or 4s. Now, this follows that if we were to make it a 3D shape, we would have a rectangular prism with optimal volume and surface area. It would become a cube because it's like taking our square and I am making it, extending it to make it three-dimensional. So every single side is the same. So I could say the volume is now side times side times side. So instead of length times width times height, we have side times side, or we could say s cubed. Our surface area, if we open this, we have six sides that are exactly the same. So it looks something like this. Each one would have side squared as the area. And since I have six of them, my surface area would be 6s squared. Now let's go on to some of the questions. Our first example, we need to optimize rectangular prisms. So every time you hear optimizing a rectangular prism, if it's going to be a normal rectangular prism where all the sides are present, then we know we need a cube. So let's do our first one. Our first question, we said Brooke constructs a rectangular prism using exactly 384 inches squared of cardboard. What's the greatest possible volume? What's the dimension of the prism? So recall, in our last lesson, we always said that we had to determine what was fixed and what was variable. And in this case, they told us that we have a fixed surface area of 384 inches squared. We know that surface area is also 6 side squared. Now, our other equation would be volume. Volume is what we need to optimize. So since we need to optimize this, we're going to rewrite our equation, length times width times height, or side cubed. We can rearrange our first equation and substitute it into our second. So 384 is equal to 6s squared. Let's rewrite this. So I have s squared is equal to 386 divided by 6. When I divide that, I have s squared is equal to 64. So s is equal to the square root of 64. S is equal to 8. I've rearranged the surface area equation, and I'm going to now substitute it into the volume. So sub S is equal to 8 into volume. V is equal to 8 cubed. Throw that into your calculator, and 8 cubed is equal to 512 inches cubed. On the other side, we have Basil is constructing a rectangular prism with a volume of exactly 1331 meters cubed. What is the dimension of the prism and that has the least surface area possible? What is the surface area? Now, in the equations, I'm going to write my surface area equation. I know that that is 6s cubed. Now, this is the one that I need to optimize. I know that volume is equal to 1331, and I know that volume is equal to length times width times height, or s cubed. And this value is fixed. I've created my equations. So the next thing, I'm going to rearrange my volume equation so that I can substitute it into my optimizing equation. 1331 is equal to s cubed. We're going to undo the cube by taking the cube root of 1331. Throw that into your calculator, and you'll get s is equal to 11. Now that I know my side is equal to 11, I can find my surface area by substituting it in. Surface area is equal to 6 times 11 squared. Oh, sorry, this is a square. Okay, so we're doing our exponent first. 6 times 121, and we get surface area of 726 meters squared.